Okay, my name is Gregg. I am an analytics engineer working at Cox Automotive. AutoTrader is one company within the Cox Automotive family. And this talk is about visualizing AutoTrader traffic using Spark streaming. Like a lot of Spark streaming applications, this originally started out as a Spark batch job. So I'll be talking a little bit about the larger project and then sort of tying that in with how that relates to Spark and Hadoop as a whole at Cox Automotive. Okay, so just as a general overview, we'll start with just why we're using Hadoop and why Spark at Cox Automotive. I'll dig into the details of the Spark streaming application, and then I'll finish off with a roadmap, sort of where we see Spark at Cox Automotive over the next 6 months. Okay, why we're using Hadoop. I think the picture will become clearer once I show you what Cox Automotive is. Is that not working? Good. Okay. Cox Automotive is a family of 25 companies and growing. Contains some of the flagship names like AutoTrader for buying and selling cars, for KBB for vehicle valuations, for Manheim, which is for dealer-to-dealer wholesale auctions, and a whole bunch of other companies. This slide is what our CTO showed at Strata last year. And so this is a very, very new thing. Cox Automotive was established last August. So a lot of these new initiatives, including Hadoop, are still sort of in their growth stages. So to summarize, we're at 25 companies and growing. We need something that's going to be very flexible, very scalable as we continue to add to Cox Automotive. And we need a way to sort of facilitate the joining of data across companies, right? So we have all these companies that are spanning the life cycle of a car. If we have analysts talking to each other and sharing data, we can provide insights that a lot of other companies just don't have access to. So we're going with the Hadoop cluster. It was stood up and Kerberized around August of last year. And right now we have a dedicated ingest team, which is sort of the intermediary between Hadoop and AutoTrader and Hadoop and Manheim, helping them land their data into Hadoop in a repeatable way, installing some basic logic, doing best practices, file formats, that type of thing. And then my team, the team that I'm on, sits next to the ingest team, and we work with the analysts for helping them run things like Spark. So the overall idea, we have 25 plus companies. That means 25 plus separate relational database services. And a lot of what companies want to do can be handled in a relational database. But we want analysts, especially BI analysts, to use Hadoop where it makes sense. So that involves when they want to join data from across several companies. They can do the join in Hadoop and then pull it into the relational database. That would be great. Large amounts of data. So just to give an example, AutoTrader, 1 year of data is 35 terabytes of space. That's a drop in the bucket compared to what, say, NASA's doing, but it's plenty large enough to sort of tap out some of these relational database appliances that exist across Cox Automotive. And then where Spark sort of ties in is building out business logic so it's shareable. And so that's, right now we have a lot of raw data that's landing in Hadoop. We want some way to have more than that. So we're asking AutoTrader's BI teams to map the data from a raw state to defining what a search is, defining what a unique visitor is, what a session is, that sort of thing. And suddenly that's all shareable across Cox Automotive. So that's all great. It's conceptually beautiful. It's if it works, that's a good thing. But no one's going to just jump into Hadoop cold, right? If they're used to doing what they have to do on SQL, it's really up to our teams to showcase what Hadoop can do. So we need a way to sort of prove that out. And the project is called AutoTrader's Auto Bowl. This is a big initiative at AutoTrader. It's been so for many years. And it previously had been run in SAS and Netezza, and we got clearance to run this in Hadoop this year. It involves a lot of the data wrangling from a raw state to something that makes sense to other companies. It's a very meaty project, and if we can pull this off in Hadoop, then it really demonstrates the processing time and the ease of accomplishing these tasks. So the premise is pretty simple. We have customers like a BMW, like a Mercedes, like a Honda, who buy Super Bowl ads every year. Usually there's about a dozen of them. And typically, and they want to be able to measure traffic. There's just a lot of investment into these ads. And typically, if you see a Super Bowl ad and you like that car, you might go on your phone or your laptop and search for something like buy a Kia Sorento. And there's a really good chance that AutoTrader will be the top hit or one of the top hits. So we have a lot of visibility into this online traffic space immediately after a Super Bowl ad airs. So the goal of this is to find which big game car commercial led to the greatest AutoTrader traffic increase, and we're using that as a proxy for just saying which ad was most effective. Another thing, so it's really good for client relations, but another thing that AutoTrader has done is gotten a lot of exposure is we'll publish these results the night of the Super Bowl via a bunch of press releases, and year after year it's picked up by CNN or Wall Street or USA Today, and it's pretty amazing that just a regular data munging job at AutoTrader gets national exposure consistently year to year. So we had two solutions in place. The first one, for some obvious reasons, was Hive on MapReduce. It was a new cluster. It was the most mature product. It was supported by Cloudera. Just a lot of good reasons to think that this was going to work. And also, it shows SQL's capabilities on Hadoop. We really wanted to demonstrate that using SQL, you can accomplish this really meaty job. And second, we had a Spark solution, which started out as a POC. New cluster, with Yarn, with Kerberos. We were running Spark.1.0.0, and we weren't sure if it even worked at all or would just break immediately, that sort of thing. So it started out as a POC, and if it broke, then we had Hive as a backup. So the data looks like this. We just take it from a raw state, and you can think of this as a small sample of a much taller table. So the left column is your make and model. The hours are the hours of the Super Bowl. So it ranges from 3 p.m., which is sort of when the coverage begins, till 10 p.m. when the coverage ends. And you're seeing the last 2 hours for the Kia Sedona, and then alphabetically, the next car is the Kia Sorento, and we show the first 3 hours. VDPs are essentially just sales pages for a particular car, like that red minivan is on this dealer's lot and it costs $7,200. That's a VDP page. And a search is going into AutoTrader and saying, I'm looking for a red minivan. So the way to read this table is that the Kia Sedona during the 9 o'clock to 9:59 hour had 300 VDPs and 290 searches. And maybe we care about this bottom row because Kia Sorento showed their Pierce Brosnan ad during the 5 o'clock hour. And look at that, the VDPs jumped up from 210 to 350, and the searches from 220 to 380. There's a lot more that goes into this, but just for the sake of a presentation, we'll say that that's like a 70% increase. Do that for every single make and model that showed a Super Bowl commercial, and publish the results the next day. So comparison of Hive versus Spark. This is going to be obvious to a lot of people here, but at the time, it's a huge deal for us. So minutes to process 1 hour of site activity data. In Hive, it took 18 minutes. And in Spark, it was 1.5 minutes, which was on par with what people were used to in a relational world. Another thing is that because we had access to the REPL, because we could write our own UDFs within the same job instead of having to package it and bundle it into a jar and upload that each time, and just easier ways to test and that sort of thing. We had a month to spare afterwards. It was just very rapid development. And so the idea was, okay, let's not waste that. What can we do that's cool in a month? So this is where we get to the Spark streaming for near real-time visualization of traffic. We'll go back to this previous slide and kind of say where it could be better. We lose a lot of information when we're dealing with an hour grain. Things like, if the ad showed at 5:55 p.m., should we calculate the lift on the 5 o'clock hour or the 6 o'clock hour, because there's probably overlap. And then we also lose information like, what was the pattern, right? Did people go on the site immediately after seeing the ad, and to drop off after 5 minutes, to drop off after a half hour. This is things that our clients would like to know. So how about creating a visualization that uses Spark Streaming? Here is the high-level architectural diagram, super high level actually. We have over 100 web servers that are spitting out log data as you're performing searches or doing anything on the site. It lands all the logs into essentially a NAS, and we have a Java process that is polling that NAS continuously and saying, is there any new data, is there any new data, and then pushing that new data into Kafka. We then use Kafka utils, had to write that in Scala at the time, and to pull from the Kafka topic. Did all the same processing in Spark Streaming that we would have done, that we did previously in the hourly batch job, and then output that data into an AWS queue. And then from there, we had a whole bunch of EC2 servers for handling browser requests, some extra aggregation, that sort of thing. The final output is a browser-based visualization. We really explored a lot of packages, tried to find something that would be really easy to implement, and just didn't find anything that was where the transitions were clean and just physically, it was just pretty to look at. And so we ended up just kind of hacking our way through D3 code, getting it working. If anyone's interested in this, Mike Bostic, the guy who wrote D3, has a nice page on path transitions, which was really important for us in getting this to work. Cool. So here's the video. This is what the Spark Streaming job looks like. I don't know if I can play it in here. Let's see. Nope. Let's see here. All right, I'll just play it this way here now. OK, hopefully you can see that. No? Is that working? OK, great. I don't know if it's actually running. Let me see this way here. What's that? Hit the tick? Let's see here. It is moving? It's not now. It did. OK, I'll try that again, clicking it. Is it working? OK, awesome. So this is something I did at a few nights ago. So I mean, if we launch it now, it would be about a 20-second lag. But this updates every single second. And you're getting real-time, or 20-second lag traffic of, right now, the Chevy Colorado, the Kia Sorento, the Jeep Grand Cherokee, and the Toyota Camry. And then we can swap these out sort of on the fly. So what's being plotted is the last 15 minutes of site traffic scores, which is a combination of the VDPs and searches that I talked about and a few other things. And each sort of dot that's plotted is the average site traffic score over the previous minute. So for example, at 12:48, you're seeing the Jeep Grand Cherokee with a score of around 30. That means the average site traffic score from 12:47 to 12:48 was 30. Okay, so that's fun to look at for a bit. It's fairly random throughout the day. Where this gets really interesting is during the Super Bowl itself. We had a war room for that night. We were sort of just watching this go. It started out being random throughout the day. And then sort of when the pre-game ads started showing, we started seeing some huge lifts, and it was pretty cool. Here's the first one. Chevy Colorado had 2 separate pre-game ads. The first one was right after the national anthem. The second one was after the coin toss. And you just see this just like launch into the stratosphere. It was fun to watch. You see the first hump after the first ad, sort of a trickle-down effect, and then you see it ramping up again afterwards. The second one is the Kia Sorento. This is the Pierce Brosnan ad. It actually showed around 9 o'clock in-game, and you see another lift. And then finally, this is my favorite one. This is the Chevy Colorado again. They had 2 post-game ads. So this is literally the first ad that showed after the game had completed. And you see the initial rise. And then slowly starts dropping over the next 7 minutes. And then at 10:27, Tom Brady won the Super Bowl MVP award, and his prize was like a trophy, and then also the keys to a Chevy Colorado. And so that wasn't really a classic ad, but you see the lift is very similar to what we're seeing for ads, and actually beat some of the other ads we saw that were in game. So pretty impressive, and it's a creative way to market. So what's next? Cool, we built a way to visualize traffic in real time. What do we do with it? First, there's a whole bunch of other visualization use cases. So shortly after, a week or two after the Super Bowl project, we plugged this in with the app dev team on the AutoTrader side to detect anomalies in AutoTrader metrics after a site update. So if we're fixing a bug, if we're adding a feature, there's just a lot of code, and from time to time that'll break something in something that just wasn't unit tested properly. And so a really good way to sort of identify where that happened is to calculate all of our core metrics in real time, like unique visitors, like VDPs, like searches, and a whole bunch of other things, to be honest. And then if we see a sort of just dropping off a cliff shortly after a update is deployed, we get someone on a phone quickly and fix that. So actually, it wasn't this exact one, but using the exact same logic on a separate dashboard, we found one right away a week or two after deploying it. Executive dashboards, not really worth showing, but it's just cool to have people in high places using a Hadoop process throughout their day on their computer. And then visualizations for A/B testing. This is sort of on the map. We're working on it now. Something that would show confidence intervals in real time as two different templates are faced off against one another. Finally, I want to talk about gaining BI adoption. Really, this is where it all comes down to at the end. We can create pretty Spark graphs and all that, but if ultimately we really want to get people, BI users from across Cox Automotive using the cluster. And we've been very successful with that in a short amount of time. Some notes on that. Most of our BI users are using Hive or point-and-click third-party applications. This is to be absolutely expected. A lot of them are SQL users, and so Hive is a natural transition for them. But there's been a shift, and I'd say over the last 2 months or so, we have seen as many requests for Spark from BI teams as we have for Hive. And a lot of these BI users have decided that yeah, they could try to run SQL right now using Hive or waiting for Hive on Spark. Spark SQL is not supported with our distribution, so maybe that's an option in the future. So they're willing to just learn enough Python to do things like data wrangling for the benefits of Spark. And Spark has been in use at AutoTrader, KBB, Mannheim, and Nextgear by developers. And Mannheim and Nextgear, for a while, actually, they've done some pretty impressive things with it. And then finally, I just want to talk about how we're using Python here. Because we're working on 1.0.0, the entire Super Bowl project was written in Scala, but we're transitioning that over to Python and making that a primary language here. This makes sense with the data frame API. We have the speed improvements that we talked about yesterday, where a Python job will have the same performance as a Scala or Java job. And it now supports Kafka integration for streaming. And we found it to be a much easier sell than Java or Scala. So not only would it help for Spark jobs, but for scripting or visualization or analytics packages, it's all there, and it can really help them with their day-to-day job as well. Finally, just some quick notes about onboarding users, what we're doing, what we're finding effective. We have a central Git repository with best practices, things like POM files and just starter kits for launching a streaming job on our cluster. We're providing individual support for BI Spark champions right now. Anyone who's started making the leap from SQL to Python, it's not really the point of our team, but we're doing support in the intermediate time before shifting that off to another team, just because having a few users sort of driving Spark matters so much. And then finally, we're establishing guidelines for each new user on setting Spark parameters. And this is a huge deal. Right now, basically anyone who's using Spark can set whatever parameters they want, number of executors, amount of memory per executor. And that's potentially a really bad thing as we sort of scale this up to over 100 users. We don't know of a good way to restrict that. We do that on the SQL side with these third-party applications or Impala. But if there's something that comes up in the community about restricting what parameters you can set, we'd be really interested in that. So that's it. I'll just put the streaming application back on, and I'm available for questions.
Thank you. It was a great presentation.
Thank you.
You showed one of the slides where you had, I think from web servers, it's going into a NAS, and then you had Kafka. What part of that was on-premise, or was it all on the cloud?
It's all on-premise. The whole thing's on-premise.
But then you had AWS too.
Right. So the final part was in AWS. But yeah, we have a on-prem cluster for Hadoop. A lot of things on the AutoTrader side are on-prem. They have a lot of uses for the emitter in the cloud, but the emitter itself is on-prem.
So did you have latency while bringing all that in real time and processing that on the cloud?
Yeah, so latency wasn't a huge issue for us. I mean, we were at a 20-second lag, and it really wasn't a big deal. We could have broken that down to probably about 10 seconds if we really worked at it. There's a good amount of processing in place. But for this use case, it's internal use. Getting it down to really like within 1 second, not a huge deal for us. So,
I apologize if this is a little bit out of left field. I understand that the search terms that you're using are in data streams that you control, right? The search terms are from data streams that you control, right? But I was wondering, was there ever an option to try to purchase just the Google results, the queries that go to Google, to see if you can use that information to enrich this?
No, and really, this Spark Streaming 1 was essentially a POC at this time, and then all the other projects like anomaly detection were actual uses of Spark Streaming. I mean, running it on 1.0.0, there's Kafka guarantees that are just not there in that version. So there's a lot of things where we're just really getting that data not super important for that project. And a year from now, that's something we'd look into.
So just to understand what you just said,
yeah.
You're saying this is something that potentially you might be adding in the future?
Correct, yeah.
Okay. And do you know if that is something that is commercially available? Those types of data sources, right?
You know what, that's interesting. For Google directly, no. We actually had one client or one vendor that we talked to that said they had something like that. I just won't mention it, but one of the outside data sources we really wanted to tie in to really make this a wide-scale thing is there are companies that have commercial data year-round, right? So being able to tie that in, not just for the Super Bowl, expanding it out to the entire year, something we've looked at.
Thank you. That was a great presentation.
Thank you.
I have one question about this video that you have. How much data are you processing every second?
It's
roughly
hard to say. I don't know how many logs per second.
Okay.
I don't know. I'm sorry. Yeah.
And can you talk a little bit more about how much effort went into optimizing Spark for high throughput, or for in terms of streaming? Right? Did you spend a lot of time configuring or optimizing Spark to work for this use case?
We did, yeah. And actually, I'll say that for your first question, it's the 35 terabytes that I mentioned for a full year, broken down to whatever that is for 10 seconds. So that's the math for it. As far as optimization, there's a lot that went into it. Getting that first number down to 1.5 minutes for the batch job was crucially important, just to really see how quickly Spark could process this amount of data. And so we took that optimized code and moved it over to the streaming process, and then configured the memory overhead, a lot of those parameters to really get that time down as low as possible. So.
Thank you.
Sure.
Hi, thanks for the presentation. I have just one question. So before serving the data using these D3 graphs, did you ever have to persist the data anywhere? Or if you had to, then what technology did you use?
Did we purchase data for testing this
persist.
out?
So
Do we persist data?
Yeah.
OK, so that's an interesting question. We have it in AWS for if we wanted to. Okay, we chose not to go that route because we have this hourly job that's providing all these metrics after the hour anyway. So there's really no reason for us to do that. But yeah, that was an option, and we just decided not to, just for cost reasons on AWS.
And you didn't have to do any historical trending or something?
Any what? Sorry.
Historical trending.
Any historical trending? No,
Like,
no, not
okay.
at all. Yeah.
All right.
Any more questions? I guess not. OK, thank you, John, for a great presentation. Now have a break, and we'll be coming back at 3 o'clock sharp. Thank you.